So hello and welcome everybody to this webinar on data analysis and query building with MedDRA. My name is Anne Jullenswert and I'm an international medical officer with the MSSO. And that is the function where we look at the change requests, we review and decide whether we would add new MedDRA terms. And in addition, I'm one of the MedDRA representatives on the ICH M1 PTC working group. Today I'm joined by Leander, who helps facilitate the meeting. We both will take you through this webinar that will take around 2 hours, so we have plenty of time for exercises, demonstrations, and for addressing your questions. As Leander already has mentioned, please submit any questions you may have during the webinar through the question panel, and I will take questions during the session, but also there will be time at the end of the presentation to answer your questions. Another housekeeping thing, please be aware we are using some polling questions, but this is not thought to be a very interactive webinar. So if you are used to the Let's Code Together webinars, this will have a lot less interactive things in it, because we are going to show you quite a lot of principles. We're going to discuss some tools, we do some demonstrations of tools, but it's not thought to be interactive in the way that we have a lot of polling questions. I will do some browser demonstrations and show you some important and helpful tools in the browsers. And depending on your preferred learning style, of course, you can have the browser open and follow what I'm doing, but it's also completely fine if you just relax, watch what I'm doing, and try it out later on. You can find the credentials, as Leander had said, in the chat, or you can use your normal company credentials, whatever you prefer. Okay. Before we dive into today's topic, let me share some background related to MedDRA. And I guess many of you have seen this slide before, but it's always good to recap. MedDRA was developed by ICH in the mid of the 1990s, and ICH became the owner of the terminology. It soon became clear that for this standard terminology, we also need some maintenance. So the MedDRA Maintenance and Support Service Organization, or short MSSO, was put in place by ICH to maintain and further develop and also to distribute MedDRA on contract. The activities of the MSSO are overseen by the ICH MedDRA Management Committee, which has members from industry and regulators from the ICH regions, from the MHRA in the UK, Health Canada, and also the WHO as an observer. Then we have some disclaimers to make, and I will just summarize this very busy slide. The ICH is not only the owner of MedDRA, but also owns the training material which we are using in this webinar. It is protected worldwide, but you may use the slides with the exception of the ICH and the MSSO logos if you clearly indicate that ICH owns the copyright. If you make any adaptations to the slides, you also have to clearly label that these are your adaptations and they are not endorsed by the ICH. The second bullet point refers to warranty and liability issues you should be aware of. And as it contains legal language, I'm going to read it out to you. So it says, the presentation is provided as is without warranty of any kind. In no event shall the ICH or the authors of the original presentation be liable for any claim, damages, or other liability arising from the use of the presentation. And the third bullet is not relevant for today because we will not be using any third-party slides. So what are we going to discuss today? We will first look at the PTC document for MedDRA data retrieval and presentation. Then we will address some important principles that should be considered when retrieving, presenting, and analyzing MedDRA-coded data. After that, we will look into how MedDRA, but also show you helpful MedDRA tools and demonstrate how these can be used for developing queries and what a query actually is. And at the end of the session, as well as in between, we will have a Q&A round. And I think it's always good to address questions in between. So I will ask Leander at several time points whether we received any questions, because my experience is it's easier to concentrate once your immediate questions have been addressed. So, as said, we will be using some interactive questions during the presentation, and we have the Slido tool for doing that. To join the interactive quizzes, you can either enter the website slido.com, and then when asked, you provide the number, which I can read out for you, 2157877. Or maybe easier, you can scan the QR code with your mobile phone. And I think Leander has also been so kind to add these instructions into the chat. But the QR code will also be shown whenever I switch to one of those Slido slides. So don't worry if you did not manage to join yet. And here's our first question. We would like to get our audience, to get to know our audience a little bit better. So where are you joining from today? And I see people are, many people from Portugal, India, Turkey is well represented, Switzerland. Very interesting to see from how many countries people are joining us today. And I also see that many of you managed to join the Slido tool and are able to enter their country. And yes, Germany is getting bigger. Israel, Indonesia, Belgium, Egypt. So we have a very broad representation from all over the world. I will keep this open for just a few seconds longer for everybody to be able to join the Slido and to enter their country. Thanks a lot for participating. And our next question is, what is your role in your company? That's right, director, PV, that is what I was expecting. Pharmacovigilance officer, signal management, so also data managers, happy to have you here as well. I think it's always very important for all of the people to know how data entry works, because you need to know the basics for doing the analysis, but also very important for the data managers to know what happens with the data afterwards. How are people looking at the data, and why is it important to add the data in a certain way? So very, very happy to see all these different roles who joined this webinar. Okay, then one more question. How would you rate your knowledge of using MedDRA to retrieve and analyze data? And please just say 1 beginner, 5 would be expert, or just choose something in between. So we have lots of beginners, which is also nice to see. And we will go through a lot of general principles. And yes, happy to have you all here, and I hope you will be able to learn a lot today. So, what are benefits of using MedDRA? Waiting a bit for your answers. I already see harmonization, standardization. Standardization, harmonization, yes, everybody is feeling data analysis. Yes, standardization, signal detection. Okay, proper AE coding. Yes, standardization has the highest counts at the moment. Accurate data presentation, use for ISR processing. Yes, very important things which you mentioned. Same language, also a very important thing which we have in MedDRA. And our MedDRA languages also help in adding that standardization, because it helps people to code the data in their own language, and everybody can then transform it via the MedDRA code into all other languages. Thanks a lot for participating, and all very interesting and nice things which you said. So let's first start by looking into a very important ICH guidance document, which is exactly talking about our topic today, and it's the MedDRA data retrieval and presentation points to consider document. In the poll, we saw that a benefit of using MedDRA is the standardization, and this is not only achieved by using the same terminology, which allows us to speak with one language, but it is also important to use this standardized terminology in the same way. And for this purpose, additional ICH documents were prepared and are being maintained, which provide, on the one hand, coding guidance in the MedDRA term selection points to consider document, but also guidance on data retrieval and presentation. And here you have a snapshot of the front cover of the current DRP PTC document. And for using it most efficiently, it should be used in conjunction with the MedDRA term selection points to consider document. And we recommend that you use it as a basis for your individual organization's own data retrieval conventions, or if you already have your approaches, they should not be in conflict with the general principles provided in this document. The ICH points to consider documents are developed and are maintained by an international expert working group, which is appointed by the ICH Management Committee. It has a very broad geographical representation. And the complete versions of the PTC document are released once a year on 1st of March, and they are available in several languages: English, Japanese, Chinese, Korean, Spanish, and Russian. And then, in addition, there are condensed versions for these full documents, which are available in some of the MedDRA languages, namely Portuguese, Brazilian Portuguese, Czech, Dutch, French, German, Hungarian, Italian, and Portuguese. These documents are not updated with every MedDRA release, but just on an as-needed basis, and they focus on the general data retrieval and presentation principles without going into further details for selected topics. So for an easy overview, you could read these, but for more in-depth, you should go to the full versions, which are available in the named languages. So I will also show you how to access these documents, as with many things, there are several ways to do this. And one way is and we are using the browser already, because the browser also includes a link to the MedDRA documentation. This is the old web-based browser. If you click on it, a new window opens and directly takes you to the MedDRA.org website. And you see this is in the How to Use Support documentation page. And you have the points to consider documents. And these are available in a navigable PDF format, a Word format, and an HTML format. We also provide redline versions of the documents, meaning a Word document in which the changes to the previous version have been highlighted. And you can see we have the MedDRA term selection points to consider document, the MedDRA data retrieval and presentation points to consider document, as well as a MedDRA points to consider companion document. This document is not released with every MedDRA release, but also on an as-needed basis, and it provides guidance for further specific topics. Okay, let's go back from the new web-based browser, which many of you might not have used. It's enhanced for searching, but it still has all the functionalities. And if you are looking for the MedDRA documentation, you can find it in the settings section. You can go to documentation, and if you enter the MedDRA documentation, you get this little button up here, which also takes you to the link on the MedDRA website. Of course, you can also just enter MedDRA.org And then in how to use and support documentation, you will find the points to consider documents, and below that all the documentation for all MedDRA versions. Okay. So when looking into this document, it first addresses general principles like the quality of the source data, the documentation practices, the principle that MedDRA should not be altered. It talks about organization-specific data characteristics. It also addresses characteristics of MedDRA that impact the data retrieval and analysis. And it talks about the MedDRA versioning and how that affects your data retrieval. It provides general query and retrieval guidance. And then it talks about standardized MedDRA queries and customized searches. We will discuss the first bullets today, and there is a separate webinar next week on Wednesday where we discuss standardized MedDRA queries and customized searches. So you're very welcome to also join that webinar if you're interested in standardized MedDRA queries and customized searches. Then let's look into more detail at the general principles. So quality of source data. As said in every webinar, I guess the quality of the source data, the quality of the data input is also then determining the quality of the data output. And this is discussed in more detail also in the MedDRA term selection points to consider document with principles like if you get an ambiguous term, try to get a follow-up. So what you don't fix in your data input, it's hard to fix with the data output in the end. But also other things impact the quality of the source data. So there are, if you need to convert data from a previous terminology, we often call this legacy data. If you need to convert this legacy data into MedDRA, the way you do this might impact your retrieval and presentation in the end. And there are several ways to convert legacy data, and one would be just taking the coded term and converting that by either just recoding that coded term for legacy terminologies like CoSTART, WHOART, ICD-9, and HARTS. Many of those terms have been added to MedDRA at the LLT level, so that you have this is an easy exercise. For other terminologies, you might have a map available like the ICD to MedDRA map or the bidirectional mapping between MedDRA and Snowband. So it really depends on how you convert your data. If you're converting from a term coded in a legacy or another terminology, you might lose specificity because those terminology usually did not have the same granularity in the terms as MedDRA has. So there is another way of converting your data into MedDRA, and that would be to take the original verbatim term, which was reported to for that case, and to use that term and directly code it in MedDRA. This, of course, takes more time, is more effort, but you would gain something in this, in the granularity and the specificity of the term. And in the end, it might support your data retrieval better in the long term. It might also have some difficulties, especially if you look at post-marketing medication error terms. These are often coded in the context of the case, and the verbatim term might not be easily coded into a MedDRA term if you don't have the complete case information. So you really need to balance the benefits and the disadvantages of these two ways of converting your legacy data. But importantly, when you're building your queries and deciding on the way how to analyze your data, you need to be aware of the fact how your legacy data was converted, because depending on the approach which you took, you might need to broaden your search, or you could go more narrow because you know that the granularity of MedDRA has been used for coding a term. Then the next general principle is it's very important to document your data retrieval and presentation practices. It would be good to have organization-specific guidelines, which should be consistent with the points to consider documents. You should have coding conventions for coding your cases, but also you should have your data retrieval and output strategies documented as well. If you're using SMQs, you should document how you use them. You would need to have quality assurance procedures, especially if you're building your own customized MedDRA queries. But also, it's very meaningful to have a quality assurance on the way a query is run in your database. And all these procedures should be documented so that you can follow those procedures, but also show in an inspection what kind of procedures you're following when you're doing a data retrieval. It's very important to document the MedDRA version which you use for the search. The search strategy method should be documented, as well as the version update processes. So how do you update your MedDRA data, MedDRA coded data, but also how do you update your MedDRA queries? And then it should also be described how you build, what is the process for building a customized MedDRA query. So who is involved, what kind of quality assurance you do afterwards. Is it a 4i principle? So you really need to document these things for yourself, but also for inspection purposes. So do we have any questions already, Leander?
No questions at this time, thank you, Anne.
Okay, perfect. Then let's continue. Then another general principle is that we are not allowed to alter MedDRA. And in the beginning, when we asked what are the benefits of MedDRA, we already said it's very important that we have harmonization and standardization. And that is really the strength of MedDRA, that it is a standardized terminology with a predefined hierarchy. So when an LLT is assigned during the coding process, it means that the PT, the HLT, HLGT, and SOC allocation is already predetermined by MedDRA. And MedDRA users must not do any ad hoc alterations to it, even if your database would allow to do so. Because making such ad hoc changes would put at risk the integrity of this standard and is therefore strongly discouraged. But if you really feel that something is wrong in MedDRA, you of course have the possibility to submit a change request. And we in the MSSO will consider the change request and might either accept it or provide a reason why we cannot do that. For submitting change requests to the English version of MedDRA, a separate user password is needed. And it's always depending a little bit on the organization's policy, whether these are shared with everybody or whether your organization might have a specialized group of MedDRA experts who can do these change requests on your behalf. Translation changes can be submitted by all users. And we have separate trainings on how to submit change requests. But one of the new features in the new web-based browser is that you can directly access the WebCR tool from the MedDRA web-based browser. Otherwise, you can, as usual, go via the website and search for the WebCR and find all the information you need. Then the PTC document also talks about organization-specific data characteristics. And these are very important to take into considerations. And these are completely in your organization's hands. But some of these might be fixed, so the decision might have been taken when you decided, or your company decided, on a database solution, which provides certain database structure and database fields. These can include how much information you store on the verbatim before coding. Maybe you just store the verbatim term, maybe you have an extra field to store a modified verbatim, which is sent for the coding. You can either store just the coded MedDRA term on the LLT level, on PT level, but maybe your system also stores the HLT, HLGT, and primary SOC. So it really depends on your database, what kind of data you can also easily retrieve from the database, or where more programming might be needed for you to get that information. Also, you might use a synonym list, and the synonym term might be stored, which was used for coding. Do you store secondary SOC information? So really, it's good to know your database. And we are today only discussing the MedDRA side of a query, but a database also allows to combine MedDRA terms with other data fields, that if you have a good understanding of your database, you might be able to retrieve cases in a more meaningful way than just with the MedDRA terms. Then we already discussed data conversions, and this can be the legacy data, but also consider your approaches when exchanging cases with a partner company, because you would get pre-processed cases. How much effort do you put into the processing and coding of those pre-processed cases? And do you know the practices of your partner company? So all these things really are important to know what kind of data you have and how that data was treated before you look at it. In addition, coding practices may change over time. The PTC document for MedDRA term selection is very stable, so the coding guidance for the PTC documents. But some more specific internal conventions may change over time. As a principle, try to avoid this if possible, because such changes will always lead to inconsistency in your database and make data retrieval more complex and more tricky. We already discussed a little bit that the secondary SOCs, so there might be limitations and restrictions within your database which make it difficult to get data in a certain format in a certain way. So you might consider programming efforts and additional work which you need to for getting an output in the way you want it. And then the data output will also depend a lot on the decisions which you took for your coding guidance. So the ICH MTS PTC document, the coding guidance, provides options in some cases. And for example, it provides 2 options for coding of a confirmed diagnosis with its characteristic signs and symptoms. The preferred option is to code the diagnosis only. So you would lump together all the information on that diagnosis. But the second option is also to allow to split this information and to code the diagnosis, in addition to code all the characteristic signs and symptoms separately. And this would, of course, make a big difference in how you look at your data. If you code more than one term, that increases the counts. If the diagnosis term only is coded, then it reduces counts. And it also means that other MedDRA terms could be used in your query if you select more than one term. If you just have the diagnosis term, you will not be able to look for the other signs and symptoms as MedDRA terms because they are not coded. So having this in mind helps you to decide on what kind of terms you need to include in your retrieval strategy. And if you look at a complete data set also, how do I need to interpret these case counts? Is it really so many patients, so many events, or did I inflate my case count, adverse event count, by in the way I decided on how to code the data? Then the DRP PTC document talks a lot about the MedDRA characteristics and how these can be used, how they influence the data which you are looking at, but also how you can use the MedDRA structure and get another view on your data. So let's have a look at the hierarchy first. And you know that MedDRA is a terminology with 5 hierarchy levels, with the system organ classes on top, then the high-level grouping terms, HLGTs, and the high-level terms, HLTs. And below that, we would have the PTs, the preferred terms, and the coding level, the lowest level term, the LLTs. When analyzing data, you often get an output by SOC and PT. But if you have a long output, this makes it difficult for you, because if you're looking at the cardiac disorders, you would get a mixture of cardiac arrhythmias, cardiac failures, all other cardiac events. So if for you to digest the data better, it might be meaningful to group the terms, and if you're interested in cardiac arrhythmias, to also look at the HLGT cardiac arrhythmias. And then you might see, oh, but maybe I'm not interested in all cardiac arrhythmias, but I see that the supraventricular arrhythmias have a very high number. And that is where I want to focus my attention. So it makes a lot of sense to keep in mind that PT and SOC is not the only level in which you can use the MedDRA structure to group terms. There are 2 additional levels which are very helpful if you use them. On the other hand, when using these grouping terms, be careful and make sure that you don't make one of 2 mistakes. And this is more when you're designing queries. So let's say in the first example, you're interested in the concept increased blood pressure in your data set. And you look into MedDRA and you find an HLT, which is named vascular test NEC, including blood pressure. And you say, oh, let's put this complete HLT into my query. If you would look a little bit more carefully, you would see under that HLT, you have the PT blood pressure decreased, but also, or the increased, which we are looking for, but also the PT blood pressure decreased. So it's going into both directions. So using the full HLT for your search would produce a lot of irrelevant cases. So always make sure, if you want to take a higher level term as the basis for your query, that all the PTs below that term really match the question you're trying to address. Then let's look at another problem. Let's suppose you're interested in finding cases of Stevens-Johnson syndrome in your database. This is typically described as a severe bullous condition of the skin that is often related to drug exposure. So you could search in SOC skin disorders, and you find a nice HLT, which is called bullous conditions. And yes, PT Stevens-Johnson syndrome is included in this HLT. Now, depending on how narrow or broad you want to look, you might want to look at other terms which are related to Stevens-Johnson syndrome. And yes, the bullous conditions are good candidates, but Stevens-Johnson syndrome is also described as an exfoliative condition. And if just looking at the HLT bullous conditions, you might miss all the PTs, the relevant ones under the HLT exfoliative conditions. And you might miss relevant cases. So when using the grouping terms for for building a query, be very careful not to make either of these mistakes, to include a lot of cases which you don't really need by choosing something which is too broad and unspecific. But also, on the other hand, don't go too specific and have the risk that you miss relevant cases, as with this Stevens-Johnson syndrome example. The next MedDRA characteristic which impacts data retrieval is the multi-axiality. Here you see the PT obesity cardiomyopathy as an example. The primary SOC is cardiac disorders, and it is linked to that SOC via the HLT cardiomyopathy and HLGT myocardial disorders. But then you see that there is a secondary SOC, which is SOC metabolism and nutrition disorders, and which represents the etiology of the condition. So it's linked to that via HLT general nutritional disorders, NEC, and HLGT appetite and general nutritional disorders. So which SOC is primary and which one is secondary is defined by MedDRA. And why is it important to have a primary SOC assignment? Well, again, in order to have the standardization for accumulative data output of your MedDRA-coded data, all PTs with multiple SOC linkages need to have a default or a primary SOC assignment. This will then determine which SOC represents the multi-axial PT in your cumulative data output and presentation, for example, for an integrated safety summary or for periodic safety reporting. And this representation in just the primary SOC helps to prevent double counting of events. And please note that a PT can have any number of secondary linkages, so not just one or two. And especially the SOC congenital, there are PTs that represent very complex congenital anomalies which affect multiple body sites. And all these secondary linkages are called, or all these additional linkages are called secondary, and they are all equal. There is no ranking among them. So it's the primary and all others are secondary. But this also means that the primary SOC allocation affects the way data is distributed across the terminology. For example, many hepatic disorders will be represented in the primary SOC hepatobiliary disorders, but other liver-related conditions are grouped under other SOCs, like coma hepatic goes to the primary SOC nervous system disorders, or the hepatic infections, they go to the primary SOC infections and infestations. And also in SOC surgical and medical procedure, you can find, for example, liver transplant, which is liver related. So knowing the general rules on how disorders are added to MedDRA and the SOC allocation rules helps you to check for other terms in other SOCs when you're looking for a specific topic. Per convention, the main data presentation in cumulative data output is the primary SOC. And when people are looking at their safety data, they are mostly looking at the primary SOC allocation of the PTs. But the secondary SOC allocation is a very good alternative to get another view on your data and also to present your data. Often this includes the etiology of the condition, and we will show this in a related example later on. And just out of curiosity, more than 40% of all PTs in MedDRA are multi-axial. So it's really a valid thing to consider this multi-axiality. But on the other hand, we have also some SOCs where the PTs only appear in that particular SOC and not in any other. So these are not multi-axial. This is very important to remember when you build any queries, because these PTs will not show up in any of the other SOCs, and you will specifically need to look into these SOCs to find terms of interest for your topic, for your query. And the SOCs which are not multi-axial or uniaxial, these are the ones: investigations, surgical and medical procedures, and social circumstances. So you wouldn't find any hepatic surgery in the SOC hepatobiliary, but it would be allocated to the SOC surgical and medical procedures. The lab results for any hepatic parameters would not be in SOC hepatobiliary, but you would only find them in SOC investigations. And also some other important things, like, for example, if you're interested in ear disorders, a hearing aid user is only found in the SOC social circumstances, but not in the SOC ear disorders. And Leander, this might be a good time for asking whether we received any questions so far.
Thank you, Anne. No, there's still no questions. Thank you very much.
Okay. Great. Then this is still a lot about the general principles, and let's continue with that. So just a very short check whether you followed me. So when presenting safety data, what would you do? You group PTs under the primary SOC predetermined in the MedDRA hierarchy, or you decide based on your product specifics with which SOCs a PT is grouped under. And yes, lots of people vote for the first. Some people are not completely decided yet. Let's wait a second. But I think the general picture is already clear. Yes, of course, you should group PTs under the primary SOC, which is predetermined in the MedDRA hierarchy. This is the standard output. And yes, we will go into the meaningful ways of looking at secondary SOCs, but your standard is to have the PT under the primary SOC when you're doing a cumulative data output. Thanks a lot. And then just to see whether you paid attention, please identify the non-multi-axial SOCs. And of course, as we have 3, multiple answers are allowed. So yes, a lot of people say social circumstances, which is correct. Investigations is correct. Surgical and medical procedures is correct as well. So great job. And I try to be not too nice, because I added the infections and infestations, the congenital and familial genetic disorders, as well as neoplasms. And these are all 3 important and slightly different SOCs, because these are the ones which get which are used for the primary SOC if they are one of the SOCs which are one of the linkages. They will always be primary. But they are some of the multi-axial SOCs, and the majority very correctly identified social circumstances, investigations, and surgical and medical procedures as the non-multi-axial SOCs. Thanks a lot for your participation. So here we have a practical example, because we discussed already that the MedDRA grouping levels might be helpful in looking at our data. And we are looking at an output. It's a very short one. It's just 2 slides. We are just looking at the SOC investigations, and we have the study data of a very small study of 25 milligram of my drug given to 44 patients, and placebo to 15 patients. And now we would like to understand whether our drug has a problem. And yes, it seems that we should look into the data, because 13 patients compared to 2 patients had findings in SOC investigations. But then how do we now find out what the problem is? So we have different PTs, aspartate aminotransferase increased, And if you go back, we remember, yes, this is the AST, and then we have alanine aminotransferase increased. Yes, that was ALT. Gamma glutamyl transferase decreased, gamma GT. So it's just by reading those long names, it's not very intuitive to see what kind of problem we have. So even I, as a doctor, I need to do some thinking in my head. Oh, what does aspartate? Ah, yes, that was AST. So looking at the data, we also see blood glucose increased, lipase increased, fecal fat increased, and then we have a second slide, monocyte count decreased, protein urine present. It's not very intuitive, I would say. If you now choose to look at this data slightly differently by using one of the grouping terms, we get another representation which might be a little easier to understand. So now we see the HLT liver function analysis has 16 events in the my drug group and 0 events in placebo. And it really sticks out that, okay, liver function analysis has a high event count. Tissue analysis, also something to look into. Maybe digestive enzymes, maybe white blood cell counts, white blood cell analyses. But then the other HLTs, we could at first down prioritize these. So we are looking at the same data. We just represent it with in a slightly different way by using the hierarchy of MedDRA. And it, on the first glance, it gives you an idea of where your safety issue may be. Nothing is proven yet, and of course you will need to further do a case review, you need to do medical assessment. But with this example, it shows how the hierarchy can help you prioritize your efforts. You would not start with a urinalysis because it is clearly pointing you to the liver function analyses. This is where you need to put your efforts, where you need to check first. Then, if you have time and if something happens, or if you find something relevant, you might also want to go into others. But this really highlights to you where the problem might be. Leander, any questions so far?
No questions, thank you, Anne.
Great, thanks a lot. So then we already touched versioning and legacy data conversion, but let's look at the versioning. MedDRA is updated twice a year, as you will know. We have 2 releases, one in March and one on 1st of September. The release in March is the X or the .0 release, and it is often called a complex release because it can have changes to all levels of MedDRA. The 0.1 release is a minor release, as only changes to LLT and PT level are implemented for that release. When looking at MedDRA versions, you will always need to document the version of MedDRA you use for data retrieval and presentation. And also, it's very important that your query and your data are in the same MedDRA version. But it's also important to understand what might have changed between the versions, and we're going to show some examples how that might affect your data. So how will you know about the changes made? And there are different resources. First, there is a What's New document and also a webinar explaining the changes. And this document provides a general overview on MedDRA developments. It provides summary tabulations of changes made, gives a lot of numbers. It is very recommended to always read this document because it also provides you with a background and the rationale for complex changes which were made to the MedDRA hierarchy, or if systematic changes were based on proactive change requests and implement it. So a very important document. Then there is a version report, which is part of every MedDRA version package. It is a spreadsheet which contains a summary table of the changes made and has separate tabs for example, new LLTs, new PTs. It has a tab for PT demotions, for LLT promotions. Then it shows all LLTs that changed PT linkage. It shows that PTs might have got more linkages, new secondary HLTs. It shows primary SOC changes and so on. In addition to this, all MedDRA license holders have the access to the MedDRA version analysis tool, which is a very easy to use tool, and we look at this in the next few minutes. But first, let's just discuss what kind of effect a MedDRA version change can have on your data. So this is data from the MedDRA version 22.1 and compared to the MedDRA version 23.0. And in MedDRA version 22.1, you had 15 events of fractured ischium for your drug and 5 events of pelvic fracture. Then the next time you do your analysis in MedDRA version 23.0, you see that your pelvic fracture count increased from 5 to 20. And 5 to 20, this is times 4, and you get a little bit afraid. Oh, what happened? And you start wondering, does my drug do anything to bone stability? Did my population change? Pelvic fracture is often, or maybe it was just winter, a very hard winter, and was a lot of ice in the streets, and people just fell. But then if you look into the MedDRA version changes, you see that fractured ischium, which was a PT in the MedDRA version 22.1, was demoted to pelvic fracture and is now an LLT under pelvic fracture in MedDRA version 23.0. So all the events for that PT were kind of inherited by the pelvic fracture PT, because that previous PT is now an LLT under pelvic fracture. And actually, although your data looks quite differently, there is no change in the type or the number of events. It's just the way that your data is presented in a different way based on a MedDRA version change. The same can happen if you usually first look at your SOCs and you know that your data in MedDRA version 22.1, in SOC psychiatric disorders, you had 20 events. Suddenly, when you look at the MedDRA version 23.0, SOC, your psychiatric events have completely disappeared, which is usually not happening, but suddenly you have 20 nervous system disorders events. And then this might first cause you some concern, but if you look at the MedDRA version changes, you see that a PT, which is vascular cognitive impairment, which has a clear link to the nervous system disorders, not so much to the psychiatric. It was changed. It changed its primary SOC linkage from the psychiatric disorders to the nervous system disorders. So by changing the PT, the events from the SOC psychiatric disorders are gone and are now displayed in the SOC nervous system disorders. Again, here, there is no change in the type or the number of events, but the data is presented in a different way based on a MedDRA version change. And this might first lead you to some confusion. Where is my data? What happened to my data? Why do I have this huge increase? Sometimes you can explain it by MedDRA version change. So it's important to know about these changes. So back to the MedDRA version analysis tool. It is can be used to check the extent and the impact of a MedDRA version change. It is a web-based tool and is free to all MedDRA users. And you can either access it with the URL, which is provided on the screen, and your username and password. But it has also been implemented into the new web-based browser, and I'll just show you very shortly where you can find it. Here is my web-based browser, and we have the tools section here. And if you click on it directly, you have the MedDRA version report and the MedDRA version data impact report. Let's go back to the slide. It has several features. The first feature listed on the slide is the generation of the version reports, and it provides the same format as the usual version report that you get with the new version releases. But in addition, with the MVAT, you can not only compare the new version with the previous version, but you can compare any two versions of MedDRA that you define. So when you run a clinical trial over 5 years and you have used the starting version throughout the clinical trial, you can compare this starting version with the newest MedDRA version in order to get an idea of what has changed in between and what the impact of versioning on your data would be. Then the second feature is the identification of changes in a specific data set. It's very easy to use. You can upload your data into the tool, which has, or your MedDRA coded data. You can upload up to 100,000 rows, and the tool will then show you the changes to those LLTs or PTs which are in your data. So it's not showing you everything. It also shows you the changes in the versions, but also then how this affects your data. And it provides you the same tabs as the general MedDRA version report. So you can see where an LLT was made non-current, for example, where something in the hierarchy changed, and so on. But what it will not do is it can just show you the changes to your coded data, but it does not provide you with a kind of auto-coding feature. So you cannot upload verbatims and expect that the tool will identify better terms which have been added to the MedDRA hierarchy. So this would still need to be done manually. And the third feature is a search term change, where you can identify changes to a single MedDRA term or code. This can be done also by other means. And in the new web-based browser, you have the term history, which you can check. So it's not next to the MedDRA version analysis, version generator, and data impact report anymore. But of course, if you open the MVAT from the web, you also have this search term change, where you can just type in one term and see the history of that term throughout the MedDRA versions. The MedDRA version analysis tool has an interface and report output in all available MedDRA languages. You also have the ability to run reports on supplemental changes. Supplemental changes are those changes which have already been approved by the MSSO for the next MedDRA version. And you can see what will change before it is released. Of course, these supplemental changes are updated all the time. So we are adding terms on a continuous basis, and it's not fixed as a released MedDRA version. You also have the option to include secondary SOC changes or exclude those. And we have a dedicated webinar on the use of the MVAT tool, which you can find in the trainings materials page of the MedDRA website. And I can very quickly show this to you. So this is our MedDRA website. You have the trainings, and under training materials, you can find MedDRA versioning. Oh no, it's under tools. So the MedDRA MedDRA version analysis tool. And you have the presentations, you have a streaming in Chinese, English, and Korean, or you can go to our YouTube playlist and find maybe another language. I don't know which languages we have for this particular training. Okay. Any questions up to here? Because now we would then go into the data retrieval presentation and analysis back or away from the general principles.
Thank you, Anne. We did have one question of where do I find the MedDRA version report, and then you kindly demonstrated it. So you were just coming on to that aspect. So thanks very much for that. And we
Okay.
had feedback to say, yes, they understood it. So that's great. And then we had a further question of when preparing an aggregate report, do we need to justify these changes, or is it sufficient to mention the MedDRA version used? Would the health authorities know about the changes?
Usually it's enough to describe the version used. Health authorities are also looking at the MedDRA version changes. If it's a very big change, you might want to preempt questions by discussing that or shortly describing that the change is due to MedDRA. But it's really a decision which has both pros and cons. Actually, it is not necessary. If you want to show that you looked into the data, you might want to consider to add a short sentence about it. But really depending on the topic, on the relevance of the change, whether it's one of your topics of interest, which you always discuss in great detail. Yeah. I hope
Thank you.
that
And then
answers.
we've had Thank you. And then we've had one more. If there are changes in PTs or LLTs, as sometimes happens when an LLT changes to a PT or a PT changes to a SOC, is it necessary to implement these changes in our database and notify the cases as an FU to the EMA?
Okay. This
Sorry.
goes a little bit beyond MedDRA. It is, and I will not comment on the reporting obligations to any authorities. But for yourself, for your database, it's very important that you upversion your database, because if you don't have an upversioning process, you will have several databases in your case, several MedDRA versions in your cases. And that becomes a big nightmare when you try to do a search in this, because you would not need to know all the MedDRA versions and consider all MedDRA versions for your retrieval strategies. So especially for the safety databases, you should be upversioning with every MedDRA version. For clinical trial databases, there are different possibilities, and there is also a MedDRA document called Best Practices document, which discusses versioning strategies. And unfortunately, for this webinar, we cannot go into such details, but I will show you where to find the best practice document. It's also below the points to consider documents, and this has versioning strategies, for example, for clinical trials. Okay. Any more questions?
No, that's it for now. Thank you, Anne. That's all the questions answered. So thank you very much.
Thank you. So let's continue. The PTC document then addresses the general search strategies that should be applied when investigating the safety profile of a given medicinal product. It discusses how to present the data and the impact of these methodologies for data analysis. The next slides are not yet specific to queries, but rather a general presentation of your safety data and analysis. So if you're looking at cumulative data outputs, the standard presentation should be as set by primary SOC and should display the PTs within their primary SOC hierarchy. This will present the data in a way that each PT will only represent it once, and there will be no duplicates. This will allow your data to be represented in a way that allows for the recognition of patterns and also for the identification of areas of for more in-depth analysis. When you're using the primary SOC approach, it's also important to know that there is an internationally agreed order of SOCs, which is sometimes even required, for example, by the European Summary of Product Characteristics Guideline. The internationally agreed order can be found in the MedDRA Introductory Guide. And this agreement became necessary because we have all these MedDRA translations, and the SOC presentation in alphabetical order would not look the same if you have it in English, German, Spanish, Chinese, or in any other language. So this was again done for standardization purposes, and in this instance, for the standardization of the safety data presentation. And you would know that when you start looking through a cumulative data output, you will start with a SOC like infections, infestations, the SOCs of medical relevance, infections and infestations, the neoplasms, blood and lymphatic system disorders, and then it ends with SOCs like social circumstances and product issues. And everybody who's using that same internationally agreed order of SOCs will be looking at the SOCs in the same order. And then for some data sets, the primary SOC overview might be the only display necessary in a small data set. But for bigger data sets, as shown, sometimes it's very helpful to also use the HLTs and HLGTs just to have a further grouping to more easily identify the areas of interest and to prioritize where to put your efforts. Of course, there is not just summary tabulations. You can use MedDRA in line listings. You can have nice graphs, and I will show you one in the next slide, which also help you understand your data. Limitations of the primary SOC approach can be that you have incomplete groupings due to the SOC allocation rules, and this is what we discussed with the hepatobiliary disorders, which can be spread over several SOCs, and the output might be quite lengthy. Oops, sorry. So this is one nice example of a graphical display on primary SOCs, and of course for a larger data set. And here you already see on one glance that, okay, my drug seems to have some suspected things in psychiatric disorders. It also has a lot of events in the nervous system disorders. Maybe I should look more in detail at the gastrointestinal disorders, as well as general disorders and administration site conditions. So with this, you would already prioritize where to look at. Another output which we discussed, and this is maybe too short to really show how helpful it is. If you have a big data set, it might make sense, like with the example on the investigations, which we did in the beginning, to group your output further by HLGT and HLT and have the PTs which belong together to have them grouped together in more detail. This is also a nice output, especially for larger data set. And yeah, even if sometimes you just get it as a PDF, then it becomes more lengthy. If you have it as an Excel file, you can easily remove some of you can filter, you can sort. So it's really helpful to use the complete MedDRA hierarchy for analyzing your data. So let's look at focus searches. If we looked at our complete data and have identified specific areas of interest, then often we want to have a more focused search. So either for a cluster, which we saw before, or it might also be that we know about a class effect which we want to identify which we want to see whether our drug also has this class effect. It might be a result from toxicology or animal studies where we are afraid that it might happen in the humans, and we would like to monitor this event in our human data. Might also be a query from a regulator which we need to address. So one option would be to use secondary SOC assignments for the data output and presentation, because as you saw, some things are multi-axial, and they, even if it's not the primary SOC for the hepatobiliary again, so hepatic infections are not in hepatobiliary, but they would also be displayed in the hepatobiliary as the secondary link. So looking at the secondary SOC might already help you to get a more comprehensive view on medically related events. If you're doing it in a cumulative output, you need to be very careful, because then the same event may be counted several times. But if you just look at one SOC, this is not going to happen. Then, of course, if you're dealing with a larger data set, or also to account for the uniaxial or the non-multi-axial SOCs, you might consider using a query. So either a standardized MedDRA query if it exists, or you might have a customized search either through a modification to an SMQ, or if you need to set up an ad hoc query. But let's first focus on the secondary SOCs and see how these can help you in better understanding your data. So let's assume we have a data set of events, not too many, it's just 3 pages, and we are asked to assess whether this drug has a problem with autoimmune diseases. It could, for example, be that you're assessing a new drug which your company wants to buy. This is usually done under time pressure. So you get this data set, you're asked to provide a very quick answer on, do we really see a problem with autoimmunity or not? Now, when we're looking at the data, we are lucky, because some of the terms already say autoimmune neutropenia, so we know, okay, should be autoimmune. Then there are others like Evans syndrome. I'm not so sure what this means. We have autoimmune myocarditis. Yes, autoimmune. Here, polyglandular autoimmune syndrome type 1. Okay, should be autoimmune. What about Burchard chorioretinopathy? Okay, autoimmune uveitis. Okay. Primary biliary cholangitis, hepatocellular injury. We have a clear one. In-SOC immune system disorders. We have autoimmune disorders, which is a nice one. But then, if I remember correctly, polymyalgia rheumatica, rheumatoid arthritis. Well, it would take some time to check all these conditions in medical textbooks to see which ones of these are autoimmune. So let's see how one of our MedDRA tools could help you in getting a quick answer. And this is where we want to show you what our browsers can do for you. And let's just recap shortly. We have 3 at the moment, 4 MedDRA browsers. We have the MedDRA desktop browser, which can be downloaded together with the release files and is then independent from the internet access. And we have 2 browsers which are accessible from the internet. One is the MedDRA web-based browser, and the other is the MedDRA mobile browser. The MedDRA web-based browser has been updated and enhanced. And it now has a cleaner, more reduced user interface, which is specialized on searching MedDRA terms. And as it is already available and we want users to get used to it, I will do most of the presentations today with a new web-based browser. But I will also show you in the old web-based browser where the same functionality is located. So again, for the features, if you want to use the MedDRA browsers, each of them requires a MedDRA ID and a password. You can search for MedDRA terms as well as for SMQs. It supports all MedDRA languages, and it even has a language-specific interface. And what we're also doing today is it has the ability to export your search results and a research bin, and then you can file it to your local system. And this is only for the desktop and the web-based browser. The mobile browser does not have this ability. Then we have some further features, which are viewing the primary and secondary link information. You can upload terms to run against SMQs, which we will also do and discuss in the next webinar next week for SMQs. And you have advanced search options where you can use not or in addition to just typing the words. And what is special for the web-based browser, you have the ability to also view supplemental changes in the next release. And again, supplemental means that these are change requests which have been approved, but which will be implemented in the next MedDRA release. Okay, so this is again my data set. Now it's compressed to one page. You see here the primary SOC do not really help us because there's just one term in the immune system disorder SOC, which we have here. Now one question to you again. So we have several options to check the hierarchy information, including secondary SOCs, and I would really like to know with which ones you are familiar. And you can give multiple answers, but use the option which you are most familiar with as your first answer. I would be very interested in seeing how you respond to this one. Let's wait a second to see what other people say. Okay. I think this is kind of what I expected, that most people will know that you can see the term details in the browser, and I will show you shortly. But I'm very glad to see that even quite a lot of people know the hierarchy analysis tool. And yes, of course, for all those who don't know any of these options, I think you're completely right in this webinar because I will show you. And we will use the research bin for something else today, but you will also see that it can be used for looking at the secondary SOC information. Okay, let's move on. And we're going to discuss the hierarchy analysis. You need to upload, you can upload your terms and a longer list of terms in a spreadsheet. And then it gives you the options to export either just the primary hierarchy or also include the secondary SOC information. And you can decide whether you want to see the HLGT, the HLT, or whether you just want to have a shorter spreadsheet where just one of those grouping terms is included. And you don't need any programming, but you will need to prepare a properly formatted spreadsheet of your data, which you can upload into the hierarchy analysis tool. And I have prepared such a spreadsheet. Let me open it for you. So we have in the first row, we have a header line which says row ID in column A. Then we have the MedDRA term in column B, and we have the MedDRA code in column C. The MedDRA code is not necessary if you're using the English MedDRA terms, but if you're using any other language, you would need the MedDRA code as well, in addition to the term or just the MedDRA code. So this is a properly formatted Excel spreadsheet. I will close it because if I keep it open, it will not work. And I will just very, very shortly show you in the old web-based browser. Again, here is the button for hierarchy analysis, but we will do it in the new web-based browser. Usually when you open it, you start with the view where it shows you the SOCs. And before we go to the hierarchy analysis, let's just search for a term. Osteochondral injury is one of my last searches. You find this LLT. And if you say open details and occurrences, you just need to do it the first time you click on you open a new term. It will show you the MedDRA code, the MedDRA term, and the currency, as well give you the overview on the SOCs. So the primary SOC is injury, poisoning, and procedural complications, and it has a secondary link which goes to musculoskeletal and connective tissue disorders. And what is also very, very nice is that it also shows you into which SNQs the term is included. So this term is in accidents and injuries SNQ, and it's in the narrow scope and an active term. Sometimes you have a mapping relationship for this term, and it shows you from which or to which other terminology it can be mapped. Okay. But let's start with the hierarchy analysis tool. You find it under this Tools button. You see it has the MedDRA version report, MedDRA version data impact report. These are the enhancements in this new MedDRA browser, which are not available in the old one. For this, you would need to go to the website if you're just using the old browser. Then you have the hierarchy analysis and the SNQ analysis. Both of these are also available in the old web-based browser. If you click on hierarchy analysis, it has a slightly different look than on the slides, but it has the same functionality. So you have your export options. We want to look at secondary SOCs, so yes, it's good that it's ticked. And we want to have the complete hierarchy. Our version is English, and I'm MSSO personnel, so I already have the new version. You would just see the 27.1. When we click next, we can upload a file, but it also provides you again with the information you need on how your file should look like. And you see that the header here is slightly differently called than mine. So it's just important that you have a header row and that the MedDRA terms are in column B and the MedDRA code in column C. And it also tells you for English language, but for other languages, what kind of information you need to include in your spreadsheet so that the tool can work with it. So we select the file, and it's this which I prepared. The tool needs just 2 seconds to run, and I open the file, and we see certain things. This says it's the hierarchy analysis, including the secondary, or this is my file name. It says it includes secondary SOC, HLGT, and HLT, and it gives you the MedDRA version. It also provides you the date and time when this analysis was done. So I'm trusting this tool and enable the editing because I want to sort and filter my file. And you see here, this is the row ID which we had. These are all the terms which we had in our list. And you see directly some are repeating. So these are the ones which are multi-axial, and most of them have 2 links. And you also see it here in the column M that you can see what is the primary and what is the secondary SOC. So the primary SOC has the yes, and the secondary SOC has a no. And we can now use this spreadsheet to filter for the HLGT autoimmune disorders. And ta-da, we see that all our autoimmune PTs, we assumed correctly that these are autoimmune disorders, but we also see that Evans syndrome, where we're not quite sure what it is, but also birdshot chorioretinopathy, primary biliary cholangitis, polymyalgia rheumatica, rheumatoid arthritis, and vitiligo are also considered autoimmune disorders. So this really gives us a very quick and easy overview of the secondary linkages of these terms and which of these are autoimmune. Of course, in Excel, you can also do it differently. You could also sort, and we're looking for autoimmune, so sorting A to Z would be good. And you get your terms in a collection. So I like the filtering option better, but if you're using Excel, you can do different things to see your data. And again, just one of these terms has the primary SOC as immune system disorders. And that is our term, which is called autoimmune disorder. Okay. This is again the output which I showed you. Here it is sorted by HLGT, and we see these 11 autoimmune disorders, which are also linked to, with a secondary link to the immune system disorder SOC. And if we combine this information with what we had before, you see that we have quite a lot of events for autoimmune disorders. It's always difficult to take a number of events and make a number of cases out of it. So be very careful, because a patient, of course, might have an autoimmune myocarditis, but also the rheumatoid arthritis. So you cannot just calculate and come up, but you might want to check how many cases this really are before you give an assumption on how many cases. But for the events, you have a nice representation of which ones are autoimmune and the extent of the problem. Let's see. And I think, Leander, this would also be a good time for questions again, if there are any.
Thank you, Anne. No, there's currently no questions. Thank you.
Okay, great. Then for the last half hour, we will talk about developing queries using MedDRA and discuss first what is a query. So on the left-hand side, you see that you have a database, either a clinical trial database or a safety database, in which you store your cases. And in those cases, you also have the information on the coding to certain LLTs, depending on your condition. Then if you want to look at cases for certain topics, you have a query which describes that topic of interest. And that query is usually defined by PTs, which have their, and it's by convention, all LLTs under a PT are also included in that query. So depending on your database, how you store your data, you could either match the PTs or the LLTs. And if you find a hit, so the case includes, for example, LLT1 and my query list contains LLT1, you would take that case and put it into your output. So it can be either a PDF format, or you get an Excel output, or it's in your database system where you look at the cases, but they would be grouped together for you to review. And this, the query is the description of what you're trying to match with your database and which cases you're trying to retrieve from your database. And today we will just focus on how you can use MedDRA terms to build your query. But I think it's always important to remember that there are other database fields which can also be helpful to refine your database output. So you can identify a population by the age information, for example, which you store in your database. And you could say, I want this query, but I'm just interested in children aged 5 to 8. Or I just want pregnant women and I want to look at a certain topic in pregnant women. So please don't disregard other database fields which might help you in defining your search output. But we are just focusing on MedDRA and MedDRA PTs and how you define which PTs would go into your query. And it's very important, and maybe the most important principle, that you have to know what you're looking for. So it's very important to define your condition of interest, and you need to have a clear understanding of what you're looking for based on good and reliable references. So please invest time and effort into reading up on the topic you're investigating. It helps you in defining the query, but it also helps you then later on when you're looking at the cases, because some cases you might retrieve are not really the topic you're interested in. So getting this pre-knowledge is very important. Based on this definition, you would develop inclusion and exclusion criteria. And you would also, depending on the question you want to answer, you might go quite narrow or quite broad. So you could say, let's go back to the Stevens-Johnson syndrome. I just really want the cases which had been reported as Stevens-Johnson syndrome, because then I know that somebody with enough knowledge about that disease really put the diagnosis to it. Or you could say, oh, but I'm really afraid I would like to see everything. Every skin disease I want to see to make sure it's not a Stevens-Johnson syndrome. Of course, you need to find a balance between going too narrow and too broad. And other exclusion criteria might also be that if you have a drug which is only used in adults, maybe you don't want to include the neonatal forms of a certain disease. It's just things that you can consider for in and exclusion criteria. When you start building your query, it's often good to look at grouping terms, because some of those grouping terms already describe your condition, and they also group a lot of the relevant PTs below. But please don't forget to look at the non-multi-axial and other support SOCs, because those terms will not be found in your disorder SOC. It's very important to also look at the PTs which are close to the one which you're interested in or which you already picked, because these neighbors, they could be relevant as well, because they are related to your topic. And also, if you see that one PT also has a secondary location, it might make a lot of sense to look into that secondary location as well. Usually, we try to avoid LLTs in query building because they are too granular. And but sometimes it might be meaningful to also include LLTs, or if you don't want to include them, to look into some PTs by looking at the LLT, at an LLT representation as well. And then when you're done with building your query, you should store it for future use. And also, if you reuse it, to review the impact of newer MedDRA versions on the content, and on the one hand to see what changed in MedDRA, but also whether there are other PTs which you would need to include into your query. It's also very important to document your in- and exclusion criteria and how you build your query. As well, it's very advisable to document how broad or how narrow your search is, and how you refined your query for specificity, or whether you wanted a very broad one for a lot of sensitivity. And this documentation helps others who might be asked to look at this same particular search topic, whether they can reuse your query or whether they need to adapt it. As well, it's also a very good basis for argumentation in case somebody questions your approach. And often you use a query because of a regulatory request. And then it's also very important to know why you decided to go with this specific set of PTs and not broader, not more narrow. So store it, maintain it, and document what you did. Let's look at an example, and we target the cardiac arrhythmias. And for this one, an obvious starting point, once you open the SOC cardiac disorders, directly the HLGT cardiac arrhythmias jumps at you. So if you're doing a top-down search, you directly find a lot of relevant terms for that. But then also if you use arrhythmia in your search, and I will show you this, it's called a bottom-up search, but it also gives you very important information. Let's go to the SOC and just type arrhythmia. You click on this, it opens, and you see, yes, HLGT cardiac arrhythmias, perfect. It's going to SOC cardiac disorders. But then what it also shows you is that there is an SMQ called cardiac arrhythmia terms, non-specific SMQ, which gives you a very good hint that maybe you don't need to spend all the effort to build the query, but maybe somebody already did it for you. But we're not discussing SMQs today. So this is just an example of how a query should be built, and not and we just follow that approach. So we can look top down, starting from the SOC, going through the HLTs, which are important, then bottom up to also see whether there is already an SMQ. But then also we need to think about the non-multi-axial SOCs. And one is, of course, investigations. And we might want to look into the HLT ECG investigations and heart rate and pulse investigations, where we would find a PT like heart rate irregular, which is a good one for an SMQ for cardiac arrhythmias. We also might want to look into the SOC surgical and medical procedures. And in the HLT cardiac device therapeutic procedures, we might find something like implantable defibrillator insertion, which is often done for arrhythmias. Or we might find the PT cardioversion in HLT cardiac therapeutic procedures NEC. And as a note, these pacemaker and other cardiac therapeutic procedures terms were not included in the SMQ cardiac arrhythmias. So it's really how broad do you want to go? What do you include? What is excluded? And very important to describe these in- and exclusion criteria. And then also, if you want to go broad, you might want to consider signs and symptoms which cardiac arrhythmias can lead to. So fatigue, shortness of breath, dizziness, palpitations, chest pain. And you might want to look into HLTs like disturbances in consciousness or neurological signs and symptoms, the cardiac disorders NEC, and so on, the dyspnea for the shortness of breath. So there are a number of areas that might be relevant to check, but always depending on your in- and exclusion criteria. And then lastly, there are also PTs subordinated to the HLT death and sudden death. And there is, for example, the PT cardiac death and sudden cardiac death. So depending on how broad you go, maybe you would like to include these as well in your query on cardiac arrhythmias. And this is a data set which shows a line list or short summary tabulation of patients, and we are trying to decide whether some of these might have been cardiac arrhythmias. So we have nausea, vomiting, which is very unlikely to have been the only things related to the cardiac arrhythmia without any further. So this would not be a case of high priority. Sudden death, at least for the outcome, we would like to review. Then we have the ECG abnormal, dyspnea, and cardiorespiratory arrest. Yes, we would like to review. Case of breast cancer and postmenopause, rather unlikely. A syncope after palpitations, yes, that could be something. Then we have a pacemaker-generated arrhythmia. Yes, this is definitely an arrhythmia. Atrial fibrillation and the cardioversion after it. Yes, it's an arrhythmia case. A long QT syndrome congenital. Well, we might want to look into it, although maybe not with the highest priority. Cerebrovascular accident. This is said unlikely. Somebody might say yes, but if you have atrial fibrillation and you develop emboli, you might have a cerebrovascular accident as well. So it's really looking at cases is often medical judgment, and that can be different from person to person how you prioritize the cases. But you see, on what we wanted to show with this slide is that if you look at the events, there are not many which are really in the cardiac disorder SOC. There are lots which are in others like congenital, social circumstances, surgical medical procedures, nervous system, and so on. So you cannot just rely on cardiac disorders to find all the cases and to fill your query with all the relevant terms you might want to look at. So now I would like to show you how to build a query, but we're not going to put all the efforts into reading about cardiac failure I chose. But what I wanted to show you is how you can use the MedDRA browser to collect terms and export these terms into a research bin, and then also provide a spreadsheet to your programmers and so on. So let's see. I would like to have your help with this query and would like you to provide some suggestions for which PTs we should search in a query for cardiac failure. You can provide multiple answers, and I keep this slide open. Chest pain, yes. Chest pain. Yeah, now heart failure, cardiac failure. Let's start with the ones which really put the finger to it. It's good that you add a lot of these other terms as well, because this is where we will see that we need more than one SOC. But yes, cardiac failure, we will start with cardiac failure, of course. Heart failure, yes. Very nice. Difficulty breathing, yes. Edema is a very important one. Shortness of breath, yes. Fatigue is one, yes, which I would also have directly taken. Okay, then I keep this open. You can continue typing, but I will switch to the MedDRA browser to show you how we would start with it. So let's start with the cardiac failure search. And if you click on the LLT, it shows you, yes, we are lucky there's also an HLGT, which is called heart failures. Very nicely. And then again, we see, we also have an SMQ, which is cardiac failures. So in a real world setting, we might not continue now with the browser, but we would first go to see the SMQ introductory guide. But for demonstration purposes, we don't follow the SMQ lead now. We just go to the browser, and it will open, as you know from the old browser, it will open the tree view of the SOCs. And you see we are located in cardiac disorders. We have the HLGT heart failures, and we close this one, and we have heart failure signs and symptoms. We have heart failures, NEC, left ventricular failures, and right ventricular failures. At the moment, we are interested in general. So let's see what we have. I think the right ventricular failures, we have lots of PTs which are relevant, some which I would not have searched for. Shushin beriberi. It's not really something I know. We also have the left ventricular failures. We see a lot of those. And here you also see a neonatal term. So if your drug is just used for adults, you might consider not to add it, but why not? We already see that ejection fraction is important for heart failure. So maybe that is our next search, because the evaluation of ejection fraction would be in the investigation SOCs, of course. Then we have the heart failures, NEC, cardiac cirrhosis. Of course, this is something which is already a very advanced stage. And heart failure signs and symptoms. These are already quite broad. Ascites can have very many other reasons, same as peripheral swelling. All of these are terms to consider, but which might also bring a lot of noise to your data set, depending on what kind of patients you have and so on. So let's maybe start by choosing the left ventricular failures. If you want to add terms for later export, you can right click on the term, and you can say add to research bin, and this would add the HLT name to the research bin. But what is also really nice is you can add selected levels to research bin. And maybe we take this one, because then we get to choose which level our research bin should include, and I like the PTs. So it adds all those PTs directly to the research bin. And it also directly shows you what is the primary SOC, what is the secondary SOC. Let's do the same for the right ventricular failures. Add selected levels to the research bin. And we say next. And I think there's not much speaking against the heart failures NEC. So we also take that complete HLT. But then for the heart failures, I feel it's maybe too broad. So let's only take the hepatojugular reflex. And then we just say on the PT level this time, you see the PT is highlighted, add to research bin. Because we can, of course, also take the add selected levels, but then we can just, it would be the same in this case. And just to show you again, I guess you know it, we have a legend describing that this blue one is a multi-axial term, which is primary to this SOC. Then we have the multi-axial terms, which are secondary to this SOC. And we have the uniaxial primary term. So this is just linked to this SOC. And that is why I picked this one now. And I won't pick all the green ones. We could take the blue one, because it's at least the primary one. So we add this to the research bin. Then I just said, let's look at the ejection fraction. So we close our research bin and look at ejection fraction. Oops. And we find a nice term, ejection fraction decreased in investigations. And remember, investigations is one of those SOCs where we just have, which is uniaxial, so we will not find this term anywhere else. So we take, let's look at the PT level, because otherwise we go through too many PTs. So this one is the one which we want to add to the research bin. These ones are going to the ventricular failures, and we've already added them. So let's find one more. We said that we want something. Let's maybe find something in the SOC, surgical and medical procedures. So in the worst case, you might need a heart transplantation. And so you find a heart transplant, which is in SOC, surgical and medical procedure, and it also has a cardiac implant, which goes to the same PT. So let's take the heart transplant, and then in the interest of time, I add to research bin. We will not continue. We will just rename the topic to cardiac failure, and then we can export the selection, and it opens directly a nice Excel spreadsheet where we see a long list of terms. So by adding them not one by one, we quickly came up with a query of 45 relevant terms. You have the MedDRA code, you have the term level, which is all PT, and you see that we have also whether it's primary or secondary SOC. So let's go back. This was actually the to show you how the research bin function works. And maybe we take some questions before we go through the lessons learned. Leander, do you have any questions for me at this point?
Thank you, Anna. Currently no questions, but thank you.
Okay, then let's look at what we discussed today. We could see that MedDRA is a very powerful tool for data retrieval, but it requires both a solid MedDRA medical knowledge, but also a solid MedDRA knowledge in order to identify the relevant PTs. But also, as well, you should know your database and how the data was treated before you apply your queries to it. The size and the complexity of MedDRA make the terminology much more useful compared to the lack of specificity of legacy terminologies. But it may require a more creative approach to retrieve the coded data. So you need to know that you need to look at the uniaxial SOCs. You need to know that you need to look into several other disorder SOCs potentially to get all the data together. You can see that query building needs time and resources, and therefore it is well worth the effort to share the query and to store it and to maintain it for further use. And now we could also see whether we have further questions.
No, I'm just checking the questions now, Anna, and no more questions have come in. Thank you.
Okay, great. But I think it was well worth to address questions in between. So let's see. Today we discussed the topics in the MedDRA data retrieval and presentation points to consider document. I showed you where you can find that document. We discussed applications of MedDRA in data retrieval, in the presentation and analysis. And we discussed and demonstrated the use of MedDRA for developing queries, especially the research bin functionality of the MedDRA browser. If you are interested in more information about the MedDRA topics, there is the MedDRA website. You can always contact the MSSO help desk with your questions. But we also have a frequently asked questions section on the MedDRA.org website where you may find answers to some of your own questions. Then we have the link to the MedDRA browsers. And this one is still the old web-based browser. And I added a slide on how to find and open the new web-based browser. You can search for it. You can go via the tools and the how to use the tools. And I highlighted in yellow that you have the link to open the new web-based browser if you liked what you saw today. And then we have further contact details if you need to submit a change request. This is the website where you find the description on how to submit a change request, but also the link to the web CR tool, the web change request tool. You see the link to the training schedule, but I think you all found it because you managed to register for this training. But it gives you also information about upcoming trainings. It has a link to webinars, to recorded sessions, also to the face-to-face trainings, and it gives you a link to the YouTube channel of the MedDRA MSSO. And then as well, a link to the MedDRA support documentation, which I also showed you, where you can find the PTC documents, but also the MedDRA documents related to each MedDRA version. Then MedDRA is on social media, so you can follow us on Facebook, LinkedIn, X, and on YouTube. There are some WhatsApp groups and in different languages, in English, Spanish, French, Indian, Russian, and Arabic. And you can scan the QR code if you want to join those. And there's a Chinese WeChat group. Yes, and then of course you have the possibility to contact the help desk or even to have a help desk live chat. And I think that is clear. And with that, we are at the end of the webinar. And in case there are no last minute questions, I would say thank you.
No, there's no more questions come in. So thanks everyone, and thanks for all your feedback. I'm seeing your emojis, so thanks very much. It seems like everyone really enjoyed it. So, and thank you, and a great webinar.
Thank you, Leander, and a very special thank you for facilitating, for looking at incoming questions and sorting them for me. It's been great working with you, and thanks to everybody for joining today. And maybe I see some of you next week for the next webinar on SMQs. Thanks again. Have a good day.
Thanks
Bye
everyone.
bye.
Bye bye. Bye bye.